Good morning everyone. My name is Nitin and today we are going to study relation and function further. So the first topic of today is what is relation. In order to know what is relation, we are going to have two sets, that is set A and set B. Let there are three elements in set A, that is 1, 2 and 3, and three elements in set B, that is 4, 5 and 6. Let us say that 1 is connected to 4, 2 is connected to 5, 3 is connected to 6. Now we have a relation between two sets. So what is relation? The connection between two sets is known as relation with some conditions in it. So how we can represent relation here? Relation is equal to x comma y such that y is equal to x plus 3 for every x belongs to A and y belongs to B. So this is the representation of the relation. That is, if we put the value of 1 here, we will get, put the value of 1 here, that is y is equal to 1 plus 3, you will get the value of y as 4. So your points will be 1 comma 4. Now put the value of 2 here, you will get 2 comma 2 plus 3, that is 5, and put the value of x here, 3 plus 3, that is 6, 3 comma 6. This will be our relation R. Any doubt? Now let us move forward with another example. That is, let us say we have a, firstly take an example. We have a relation R, x comma y, where x is equal to y. Say x belongs to A and y belongs to B. Represent the set A here, represent the set B here. Now if we put the value of x belongs to A, say natural number, and B belongs to natural number as well. No, we represent integers here, say. So what are the integers? Minus 4, so on. Firstly, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, so on. And natural numbers are 1, 2, 3, 4, 5, 6, 7. Here x is equal to y. It means 1 is going to be equal to 1, 2 is going to be equal to 2, 3 is going to be equal to 3, 4 is going to be equal to 4, and 5 is going to be equal to 5, and so on. So here this set, the first set, is known as domain. The second set is known as codomain. And the values that we are getting is known as the range of the function, because these values are not related to A. Any doubt? Domain, codomain and range. Please take the screenshot if you want. Now we have to know what is function. A function is a special type of relation. It means it represents this relation also. If we say that here f of x is equal to x, the x is the value of domains and f of x are the values of codomain, or you can say range. A function is a special type of relation which have some conditions in it. Any doubt? So we know the 5 terms here. First is domain, the set, or we can say the input value in any function is known as domain. The output value in any function is known as range. The set, another set, the whole set of a relation is known as codomain. Any doubt? Now moving forward, we are going to solve some questions here so you can get a better perspective of what are domain, range and codomain. The question is, let A is equal to 1, 2, 3, 4, so on to value up to 12, and R be a relation from R be a relation from A to A, such that R is defined as R is equal to x comma y, where 3x minus y is equal to 0, where x comma y belongs to A. Now firstly we have to represent this relation from set builder form to a rooster form. How we are going to do so? Firstly, take the value of A and write it as y is equal to 3x. Yes or no? Take y here. And you have to put the value of x here and get the value of y. If you put the value of x as 1, you will get y as 3. Yes, 3 into 1 is 3. If you put the value of x as 2, you will get 3 into 2, that is 6. If you put the value of x as 3, you will get 3 into 3, that is 9. If you put the value of x as 4, you will get 4 into 3, that is 12. If you put the value of x equal to 5, you will get the value of y is equal to 15. But here we know that y belongs to A, but 15 does not belongs to A. So this element is not going to be in the set R. Any doubt? So the relation will be 1, 3, 2, 6, 3, 9 and 4, 12. Now we have to write what is the domain of this function, codomain of this relation, range of this relation. What is domain of this? Write the first elements of the elements in relation are, that are 1, 2, 3 and 4. You have to write the ordinate. And the codomain, that is the output. The input value is always going to be domain of the relation or function. And the output value are going to be the range of the function, that is 3, 6, 9 and 12. And how you can write codomain? Any universal set of this is going to be codomain. Always write the set given, that is what is the value of y? Y belongs to A. So always write codomain as what is given in the question. Any doubt? Now let us understand this question again. If relation R is given to us, we can write domain as 1, 2, 3, 4. 1, 2, 3, 4, you can write the abscissa of the points or elements we have in relation R. And as range, you want to write the ordinate values of the elements in the relation. Or the input value in any function is known as domain, and the output value in any function is known as range. Any doubt? Moving further, let us solve another example. That is, what if A is given to us 1, 2, 3, 5, B is given to us as 4, 6, 9, R is given as a relation from A to B, such that R is equal to x comma y, where the difference between x and y is odd such that x belongs to A and y belongs to B. Firstly, we have to represent this. This relation is in set builder form now, as it is explained in words. Now we are going to represent this relation in Brewster form. That is, we have to take two numbers such that their difference is odd. If you take 1 here, which number will have the odd difference with 1? That is 1, 4 minus 1 is 3, that is odd. 1 and 6, yes, odd. 1 and 9 minus 1 is 8, it is even, so it is not going to be in the relation. Now take 2 and 4 is even, 4 minus 2 is 2, that is even. 6 minus 2 is 4, that is even. And if you have to write 2, 9, 9 minus 2 is odd because 9 minus 2 is 7. Now take 3, 4, 4 minus 3 is 1, that is odd. 3 minus 6 is 6 minus 3 is 3, that is odd. Now 9 minus 5 is also odd. So our relation will be 1, 4, 1, 6, 2, 9, 3, 4, 3, 6, 5, 9. Now we have to write we have written this in Brewster form. If you have to write the domain of it, what you are going to write as 1, 2, 3, 5. Any doubt? What is the codomain of it? Write the function as it is, that is P. What is the range of this? The range of this function will be 4, 6 and 9. Any doubt? Let us move forward to another example. What if a relation is given to us? That is, let us take two sets A and B such that 2, 4, 6 and 4, 16 and 36. Yes. This relation is given to us and you have to write this relation. Write the above relation in Brewster as well as in set builder form. How we are going to do so? Firstly, in Brewster form you have to do nothing, just write the pair, that is 2 is connected to 4, 4 is connected to 16 and 6 is connected to 36. That's it. In set builder form you have to write R x comma y. How x and y are related? Firstly, we can say that either y is equal to x square, where x are first 3 even natural number. We can write this? Yes, we can. So write it as y is equal to x square, where x is first 5 natural number. So thus we have represented this R in set builder form. Any doubt? Now let us move forward. Since we have already know the definition of a function, so what type of relation or function, we are going to know that. Let R be a relation that is 1, 4, 2, 6, 3, 8, 9, 10 and 11, 12. Let R be another relation between 1, 3, 1, 4, 1, 5 and 2, 6. Let R be another relation that is 2, 4, 2, 6, sorry, not 2 6 4 6 6 8. Now whenever you see a relation and if you ask is this relation a function or not, you have to do certain things. Firstly, write the domain of it. What's its domain going to be? That is 1 2 3 9 and 11. Is it? Now see, is there any element in domain that has two values in codomain? No, so it is going to be a function. It is a function. Now look at in second example. Domain is 1 and 2. Yes, it is domain is 1 and 2. But here 1 has multiple values as an answer in the codomain. 1 has 3, 1 has 4. So this is not going to be a function. It is not a function, and the reason being because 1 has multiple outputs. Because 1 has multiple outputs. Similarly, the third case, it is a function because every set of input has different output. You can say that different input should have different output. Different input can have same output, but same input cannot have different outputs. If same input have different output, it is not a function. If different output has different input has different output, it is a function. And if different input have same output, it is also a function. It is a function because all the different inputs have same output. Any doubt? Now let us move forward. To a question, and second question, what if we have given a function f of x is equal to 2x minus 5, and you have to find the value of f of 0, f of 2, f of 3 and f of 9. These type of questions are already done in 9th class in chapter 1 point something 2.4, 2.2 and 2.4. So here if you put the value of x as 0, you will get 2 into 0 minus 5, that is equal to minus 5. Put the value of x here, 2 into 2 minus 5 is equal to 4 minus 5 is equal to minus 1. Put the value of x is equal to 3, that is 2 into 3 minus 5 is equal to 6 minus 5 is equal to 1. And put the value of x as 9, 2 into 9 minus 5, that is 18 minus 5 is equal to 13. Any doubts? Now let us move forward to the next type of question, that is, what if we have given a function f of x is equal to minus mod of x, and you have to find the domain of this function, the codomain of this function and range of this function. So what is the value of x that you can put here in this function? That is, you can put any value here, that is real number. Codomain is also going to be a real number. So what should be its range? The biggest answer is this. The range of this function is going to be whatever the value of x we put in the mod, we are going to have a positive value. And that positive value when multiplied with minus is going to yield a negative value. So the range of this function is going to be minus infinity to 0, and we have to include 0 in it, because if we put x as 0, we are going to have f of x as 0. Any doubt? Now let us move forward towards similar type of question, that is, what if f of x given to us is 3 minus 4x for x greater than 0, f of x is equal to x square minus 2, where x is real number, and f of x is equal to x, where x is real number, and also f of x is equal to 4x minus 7, where x is greater than, where x is less than 0. Talking about the first case, let us say in domain we have to put x greater than 0. What are the values that are x greater than 0? That is natural number. You can put how its range is going to be, or you can also write real number, positive real number, positive real numbers. What its range is going to be? That is right here, as since we know that x is always greater than 0, when multiplied with negative number, it is always going to be less than 0, and this makes 4x less than 0, and if we add 3 on both sides, it is 3 minus 4x is less than 3. So our range is going to be from 3 to minus infinity. Any doubt? This is going to be our range. Please take the screenshot of first answer. Now let us move forward to second part, that is this. What its domain is going to be? As given in the question, x is R, so domain is R. Codomain is also R. If you have to find the range of this, what you are going to do? Since we know that x square is always greater than equal to 0, and if we subtract minus 2 from it, you will get this 0 minus minus 2, so x square minus 2 is always greater than minus 2. So the range here should be minus 2 comma infinity. Any doubt? Now let us move towards the third question. The third question is quite easy, where we have given the domain already in the question, that is equal to R, and we can put any value of here of we can put any value of x here of real number. You will get the range of it as R as well. So this is also done. Now moving forward to last question, that is, what if the function is there? Here we can see that domain is going to be negative real numbers, and for range, since we know that x is less than 0 given to us, and when we multiply a positive number with x less than 0, it is going to be less than 0, and if we subtract minus 7 from both sides, we are going to have 4x minus 7 less than minus 7. Any doubt? So our answer is going to be minus 7 to minus infinity. Any doubt? So the range is going to be minus infinity to minus 7. Based on this, I am going to give you some homework so you can find its range. first question be, what if f of x is equal to 7x plus 4 for x greater than 0. Second is f of x is equal to x square plus 2 for x is real number. For third, f of x is equal to 2x for x greater than 0. And fourth, what if we have given, not x, take it as x plus 2. F of x is equal to x raised to power 4, where x is real number. That's all for today's class. Here the chapter ends and we have completed the second chapter, that is relation and function.